Let me talk about the Moivre's formula. Which is the following. If you take r with angle theta and you take the nth power of it, can you guess what you get? Oh, I guess it's easier if you change it to Euler form. If you change it to Euler form, what do you do with r? How does this n work on this? R to the nth power, right? And then, how about this part? E to the I n theta, right? Therefore, if you write it in terms of this polar form, it would be r to the n. That's called de Moivre's formula. Now, because a lot of books don't use this symbol, this notation, they would usually write it as r times cosine theta plus I sine theta, rather than this. And it's not very fun to write all this out, but if you write down the de Moivre's formula here, it looks kind of complicated. Yeah, but I'm only mentioning this so that when you see it in the different textbooks, you don't get confused. But for us, we'll use this simpler version. Okay? Now, when do we need such a thing? Oh, give you some example. If you have, say, 1 plus square root of 3i, and you were asked to take, say, 13 powers. Is that too much? I think that's too much. 11 powers. Let's see what this gives us. You could do this explicitly, right? You can multiply 1 plus square root of 3i to itself twice, and then it just gets multiplied. You just multiply until it reaches 11. Okay. But that's probably not what this question is asking you to do, right? Because it's kind of pointless. Why would somebody ask you to do this 11 times if that was the only way? There should be a better way. And the better way is the following. First, let's think about the norm of this number, the magnitude of the number. What is it? Square root of 1 squared is 1. Square root of 3 squared is 3. So you get 2. 2 is the magnitude. So here's 1, and here's somewhere square root of 3, and it's saying this should be 2. Do you know this angle? I mean, we could use tangent inverse of radical 3 over 1, but sometimes if you know that's one of those special angles, you can just judge from the graph. What is this angle? 60 degrees. It has to be 60 degrees, right? Okay, so it must be the 60 degree. Which means this is what you're trying to do. You're trying to take the 11th power of 2 angle 60 degrees. Therefore, this is 2 to the 11th power, angle 11 times 60 degrees. using the de Moivre's formula. Let's see, this is 6600, 660, and let's subtract 360 to get the full terminal angle, which is 300. And 2 to the 11th power is 2048. That's how it simplifies. And if you try to think about what this means, it's 60 degrees going this way, right? Now, this can be thought as 2048 times 1 angle 300. So now think about what this value is if this length is 1. It's almost like this one. This is length 2, but that has 1, so you have to take half of it. So what would you get? First, what's this length? Here's 1, with this being 2. Well, in that picture, it's 1 half. It's half of it. What's this coordinate here? It's half of what we have here. So it's vertical 3 over 2, but don't you see something strange here?
Negative?
It should be negative because it's on the x. So we know that this is 2048 times positive 1/2 minus radical 3 over 2I. And if you multiply, you get 1024 minus 1024 radical 3I. That's it. Okay. Do you have any questions? Yes.
So you always have to get, so if the angle is above 360, you have to try to get it in the plane.
I mean, if somehow you can just look at 660 and immediately know what angle that is, you don't have to, but I can't do that. Usually you want to convert it to an angle that's between 0 to 360.
So yeah, the angle has to be between 0 and 360.
So let's